Good morning, class. Today what we're going to be looking at is the volumes of pyramids and cones. So again, just like yesterday, we looked at how much stuff a shape could hold. But we were looking at cylinders and we were looking at prisms. Today what we're going to be looking at are cones and pyramids. Now, to find the volume of a pyramid, the formula is actually 1/3 base area times height. And the way we get this is actually kind of neat. I can actually demonstrate this here for you. This shape and this shape have the same base area because the bottom of this pyramid at the top is the base of both the pyramid and of this prism. So how many volumes of this does it take to fill up this? So what I'm going to do is I'm going to fill up this triangular pyramid with rice. And I'm going to pour that rice into my prism. Now, yeah, I lost a rice kernel or two. But I have about that much full. So what I'm going to do is I'm going to do it again. And yeah, I realize the equation is in front of you or in the book or right there. But when I do this again, I might lose a kernel or two. However, well, still not there yet. So let's do another one. So what I'm going to do is one last one here. The volume of this here I'm going to add very carefully. And what I get is that 3 of these volumes actually is very close to 1 of these. So the volume of my pyramid here must be about 1/3 of this volume. And the way I found the volume of a prism before was I just did base area times height. So if it takes 3 of these to fill this up, I basically find the volume of a pyramid is I take the base area, multiply by the height, not the slant height, and I take 1/3 of it. That's it. Now, this formula also works for cones. But let's write this down. For pyramids, its volume equals 1/3 base area times height. And this volume equation also works for cones. 1/3 base area times height. But just like before, that base area is an area of a circle. So for a cone, it's 1/3 pi r squared h. And let's just do a quick verification. I have a cylinder, I have a cone. They end up being the same base, same height. How many cones does it take to fill it up? Well, I have one here, and I poured in. Yeah, I lost a kernel or two. That does look about 1/3. So I grab another scoopful of rice, and one here, and I add it. Again, trying as carefully as possible not to lose some rice. And last but not least, I do it one last time to see if it's actually 1/3. And as I do this very carefully, I note that 3 of these were needed to fill this up once. So again, the volume of a cone is 1/3 the volume of a prism. And there we go. That's the equation. That's how I find the volume of each. So just like yesterday, I should be able to do this. Find the volume of the solid. So if it's a prism, I first have to find the base area and then multiply by its height. If it's a cone, I find its base area, multiply by the height. Or better yet, I use R and H, plug it in and solve. So let's redraw the picture. So these are my 2 shapes. So when I look at this, to find the volume of this here, the first thing I really need to do is identify the height and the base area. I look, the height they gave me, that's from the vertex down to the base. So this 4x6 right triangle down here is my base. So my height is 9 meters. I'm looking for the base area. So to find the base area, well, that's the area of the triangle. And the area of a triangle is 1/2 lowercase b for base length times h, which is the height of my base. It's not that h. So the base here I'm going to say is 4, because that's, to me, the base length. And the height of my triangle is 6. So the area equals 1/2 times 4 times 6, or 12 meters squared. So the base area is 12 meters squared. To find the volume of a pyramid, I take 1/3 the base area times the height of my prism. So volume equals 1/3 of 12 times 9, and when I multiply all three together, I believe what I get is 36 meters cubed. And there we go. So again, just like before, whenever I'm trying to find the volume of a prism or a pyramid, what I have to do is kind of find the area of it, of the base. The height's usually given to me, and I plug it into my formula and I solve. This is pretty standard. In fact, if you haven't gotten used to it, I don't think you've been watching my videos. Here, for a cone, yeah, I could do it the way I just did it over there. However, this equation looks a lot more appealing because the height of my cone is from the base to the vertex at a right angle. So the height is 4.5 centimeters. The radius is the radius of my circle, so 2.2 centimeters. So wait, the volume equation is 1/3 pi r squared h. So isn't this volume equal to 1/3 pi times 2.2 squared times 4.5? Yeah. So the volume, and because it's a decimal, I'm probably just going to punch this into my calculator here. And when I punch it all in, I get 22.81 centimeters cubed. And there we go. That's how I find the volume of my cone, and how I find the volume of my pyramid. For pyramids, it's a little bit tougher because we first have to find the base area, but it honestly isn't too bad. Now, let's apply this to real life. Originally, we had a pyramid, originally the pyramids in Gaza had the height of 144 meters and had a volume of 2,226,450 cubic meters. Whoa. Find the side length of the square base. So find the length if I wanted to follow along the pyramid. One edge of it. How far would I walk just following along one edge of it? So, it's a pyramid. So I know I'm using this equation here. They told me that the volume was this number. They told me the height was 144 meters. And what I'm looking for is the side length. Wait, the base is a square, right? So why don't I first find the base area? Because once I find the base area, well, the area of a base is side times side. So this area is equal to side squared. Alright, so let's first find the base area. So volume equals 1/3 base area times height. So 2,226,450 equals 1/3 of the height, 144, of capital B times 144. So when I do 1/3 of 144, I believe I'm going to get this. So at this time, I'll divide both sides by 48. So the base area should be roughly 46,384.375. But I know that the base area is really the side squared. So I'm looking for the individual side length. So I'm going to replace capital B with side squared. And I'm going to take the square root of both sides. So the square root of that number ends up being something real close to 215.37 meters. All at the length of 2 and maybe a half football fields. So a small distance. And there we go. That's using the volume equation to find another unknown. So I can kind of work backwards in here. I found the base area, then I substituted side squared because the base area was side squared. Not the last problem, but the next problem is just find the volume of the right cone. Go ahead, attempt it yourself. So, I know the volume of a cone equation is this. So if I know R and I know H, I'm pretty much good to go. So right here, I know that the height is 16. And then I kind of hit a roadblock. I don't know what R is. They left it as a blank. However, I see a right triangle. I'm given one side length, I'm looking for another. One of two choices I need to make. Am I going to use SOHCAHTOA, sine, cosine, tangent, to help me solve it, or am I going to use a squared plus b squared equals c squared? Well, this one requires one side. This one requires two. To be known, I need to know their actual physical number. Do I know two sides? Dang. Not that one. So what I'm going to use instead is SOHCAHTOA. This is the angle I'm using. This is opposite then. This is still the hypotenuse. And this would be adjacent. Best choice. I have opposite. I'm looking for adjacent. Opposite, adjacent, tangent. So tangent of 65 equals 16 over R. Cross multiply and solve. I get R tangent of 65 equals 16. R equals 16 divided by the tangent of 65. And when I plug into my calculator, the radius is 7.46 roughly, and that's feet. So the radius is 7.46 feet. So wait, I now know the radius, I now know the height, and I was looking for volume, plug it in. Volume equals 1/3 pi times the radius, 7.46, squared times the height, 16. Calculator time. And when I plug it into my calculator, the volume ends up being 932.45 feet cubed. And there we go. Yeah, we might have to do problems like this before where sine, cosine, tangent, a squared plus b squared equals c squared, to find R, to find H. So that way I can solve for the problem. Alright. Last but not least, what if I wanted to find the volume of that solid? So basically, it's this shape with this shape on top. Wait, what if I found the volume of the bottom shape and I added the volume of the top shape? Whoa, that will get it. By the way, example 4 here, I only want the volume. I don't want the surface area. I don't know why I threw it in there. I want only the volume. So, what I see is two shapes here. The first shape I'm going to draw over here. The second shape I'm going to draw over here. And what I want to find for both of these is the volume. So when I look at this, the volume of a prism, if I remember correctly, is base area times height. And the volume of a pyramid is base area, well, 1/3 base area times height. And what I notice is that they both have the same base area. It's a square. The base area is the side squared, so base equals 6 squared, where the base area for both of them is 36 meters squared. I also know that the height for both of them is 6 meters. So now in each equation, when I plug it in, the volume equals 36 meters squared times the height, 6 meters. Volume equals 216 meters cubed. Over here, it still has the same base area. 1/3, 36 meters squared times 6 meters. 72 meters cubed if I do it correctly. But that's not what I'm looking for. I'm looking for the total volume, which means I add 216 to 72, and I'll get 288 meters cubed as my answer. Because I wasn't looking for one individually, I was looking for them combined. And there we go. That's how you can find a volume of something that has multiple shapes. You split them apart into shapes you know, you combine them back once you find the volumes. Alright, that's all I have for you today. Till next time.